we still have more applications here in this section dealing with the determinant. Pretty neat applications, I would say, in terms of being able to take the determinant to find the area for a triangle. If you have a tetrahedron, you can find the volume of that cubic space, and then going back here to a triangle to determine whether or not points are said to be on the same line, collinear, we can use the determinant. And then you can also find the equation of a line as well by using the application of the determinant. And then extrapolate that up to the third dimension. Here for the area, you're concerned with the second dimension, R2, but in R3, we can find the volume. We can determine whether or not points in R3 that are given are said to be in the same plane, coplanar. Also, we can determine the equation of the plane as well, all using the sophisticated determinant. Now, let me say this. This is important for the students who are taking this course, and that is for this chapter, in terms of what you're going to be tested on, the test material will stop with Cramer's rule. This information here is indeed, which is after Cramer's rule, is an application. You have homework problems here that I want to go over to make sure that you know how to do them, but you will not be tested on this information that I'm about to cover here. It's in the homework. It may be on the quiz, but I highly doubt it. But nevertheless, this information for the area of a triangle and then also for the volume as well, we will not be tested on this. So this is just information that I think is good for you to know. You can do it with the homework problems, but you don't have to study for this in terms of the exam. And the good thing about that is that some of this information, especially dealing with the volume, the determinants are like a 4x4 or 5x5, pretty large, and so I'm trying to restrict the information for the test such that you should be able to do all that information by hand on the exam. So now for the homework, you're welcome to use your graphing calculator. I use my graphing calculator for some of these very large determinants. Who has time to be sitting there, trying to work through all that? But on the test, you will need to do all and show all your work, by hand. Okay, so let's look at this one. This is the area of a triangle in the XY plane. That is the 2 space. The area of a triangle, if they give us 3 vertices, we can find that area by using this very sophisticated formula that the area is plus or minus, because the area has to be positive. So if it comes out to be negative, you just want to negate that and make it positive. So plus or minus 1/2 times the determinant of the entries there from those 3 points, which are vertices. And notice how that last column has the 1, 1, 1 in them. You just put that directly into your determinant as such. Now let's look at this problem here. So we're going to find the area here, and we'll use this formula. we have that plus or minus, and the 1/2 times the determinant of, so for the first column it's the x values, -2, 2, and 1. The second column would be the y values, 2, 2, and 6. And then here, just 1, 1, and 1. So we have that plus or minus, and then the 1/2 times this determinant. I'm going to just use whichever method you prefer is fine. I'm going to use row reduction, and I'm looking at that last column over there, so I'm just going to get rid of this one here and get rid of that one, so that first row stays the same. So this is negative times row 1 plus row 2, so this becomes 4. It's a 0 there, and that's a 0. Do that same thing here. So it's negative times row 1 plus row 3. So this is a 3, 4, and 0. Okay, so now a couple of ways you can get at that. I'm going to interchange the rows. So we have this plus or minus. You don't have to pull out a negative, but that's going to be taken care of with that plus or minus. Interchange rows 2 and 3. Okay. So we can compute now the so-called determinant. Now, I can use, we talked about if you have a triangular matrix, that the determinant is just the product of the main diagonals. But here, the main diagonal is going in the, this direction, and we're looking at here at that direction. Well, we can use that. It's just negated. That's all. So here this would be 4 times the 4. That's 16 times 1. It'd be negative 16 divided by 2, negative 8. But we take the positive since we're talking about the area, right? So this is 1/2 times negative 16, we get negative 8, but we take the area to be positive 8. Now, if you wanted to find that using cofactor expansion along that second row, so you got that 1/2 sitting out here, so then this is going to be the sign position is negative, positive, negative, so this would be negative 4 times, delete this row and column, so that's 2, 1, 4, 0. So, and don't forget the plus or minus, by the way, and I'll take care of that at the end. So this is just negative 2 on the outside. This is 0 minus 4. So this is a negative 4, and we get 8 for the area. So either way, whether you use cofactor expansion or row reduction, the determinant is going to be the determinant, right? Well, I hope that wasn't an overkill. You know, take a simple problem and just, I don't want to be that guy, you know, take something easy and just, oh my goodness. So here, determine whether or not the 3 points are said to be collinear within the plane. We can use the determinant. Here it says if and only if the determinant of this particular determinant, if we get 0. So let's see, they give us some points. So here we have this determinant. So we got the x values in that first column, 1, 4, and 5. Then the y values in that next column, -2, 1, and 3, and then we have 1, 1, 1. So we just reduce this, and so I'm going to use again just the row reduction on that last column, since those ones are kind of, you know, favorable. So -1, -2, 1. I'm going to just subtract row 1 and then add that to row 2. So this will be a 3 here, and a 0 there. And then negative times row 1 plus row 3. So this will be a 4, a 5, and a 0. So now I'm going to use the cofactor expansion along the third column. So that determinant we end up with is the 1 times delete this row and column, 3, 3, 4, 5. So this is 15 minus 12. We get 3. Well, you want to get 0 for the points to be collinear. So it's not equal to 0. So here the points are not in the same plane. Okay. So, or, you know, here on the same line, if you will. Well, it's nothing to it. Now, the last thing here for this concept for R2 is to be able to determine the equation of a line by using the determinant. So notice it's a very similar setup, but here instead of having x sub 1 and y sub 1 start off, we just have x and y. That is to help us develop the equation. And so then the points that we have here, the 2 points that are given, from these 2 points we can determine the so-called equation of the line. Well, let's look at this problem here and see if we can figure it out based on that determinant formula. So we have the determinant, we got x, and then x sub 1 is 2, x sub 2 is -1, then we have y here, put the 4 there, and then the 3. And then 1, 1, 1. Set that equal to 0. Okay. So I'm going to expand along the first row. So this is x times delete its row and column. So I have left 4 minus 3. And then minus y. delete its row and column, and so that leaves me with 2 plus 1. 2, and then this is minus a minus, so that's 2 plus 1. And then we come to that 1. So this is 2 times 3 is 6 minus a negative 4 plus 4, and that's equal to 0. So this just gives us x minus 3y plus 10 is equal to 0. And so the equation that you need is just x minus 3y is equal to negative 10. So you get the equation of the line. So, well, there's nothing to it. Now, here's a problem from your homework. I put that in here. It was kind of simple, kind of lame, so that's why I put this other problem there. So let's look at this next one. Find the equation of the line passing through the given points. So we use that determinant. We got the x here, and then we put the x values 2 and 2, and then the y. Then the y value is 0 and 1, and then here is 1, 1, 1, and that's set to equal to 0. Now, if you notice that these points here, two comma 0 and then 2 comma 1. So this just graphs a vertical line, and you know just from algebra that a vertical line has the equation x equal to those x parts, which is fixed, right? X equal to 2. So that's why I said that problem was pretty lame. I mean, we can use that determinant, but it's probably too much work to do something so simple, right? Nevertheless, I'm going to expand along the first row. Now, why am I doing that? Is to basically hold the x and the y so that I can get the equation. So this is x times, deleted row and column. So I have left 0 minus 1, negative 1. And then this is minus y. Then where the y is, deleted row and column, I have left 2 minus 2. So you see the y part is going to go out for the equation. Then plus 1. And here we have 2 minus 0. And we set this equal to 0. So here we get negative x. The y goes out, right? And this is plus 2 is equal to 0. So that implies that negative x is equal to negative 2. That is, x is equal to 2. But again, who needs to go all the way around the world when we can look at those points and just do simple critical thinking and you can get it. So if we have a tetrahedron, that is simply, look, we are given 4 vertices of this graph in R3, and we want to be able to find the volume. So we just use this formula here that's given, and again, I think there's so much going on, I'm going to just use my graphing calculator to get the results, and and I would encourage you the same. Again, this information is not, you're not being tested on, so it just serves the objective for the homework purposes. Very neat application, something that you may run into later on in life, and you can always go back and refer to it. But do you see the similarity between, these formulas and then the formulas for the area? Kind of similar, and indeed the determinant is bigger, but here was a 1/6, dealing with the area was 1/2, and then plus or minus times the determinant. So let's look here. So I want to find this volume. So you got that plus or minus 1/6 times the determinant. So we're going to, that first column, the x values 4, 5, 1, and 0. And then -2, -4, 1, and 0. And then the third column, 1, 4, 1, and 1. And then the last column, just 1, 1, 1, 1. And we just worked that on our graphing calculator, and I plugged that one in to mine. And my calculator gave me -3, but it tells us that where the sign plus or minus is chosen to give a positive volume, right? So this guy comes out to be -3, but you take the volume to be 3. And again, I just put that right into my TI-89 and just used that determinant feature. And then on the outside of that, I said 1/6 times then the determinant formula, and put all that information in there. So I would encourage you to do the same. Make life easy on yourself, right? All right. Well, let's determine whether or not points that are given, 4 points, if they are coplanar, if they're in the same plane. And again, the argument is very similar from R2 to R3. In R2, we talk about collinearity. Here in R3, we talk about points whether or not if they are coplanar, or they're in the same plane. Well, this formula for the determinant is very similar to the volume, just without the plus or minus and the 1/6. So that's pretty neat to know. So here, if you get 0, then we say that the points are in the same plane. So let's look at that, and on your calculator, we take these points. So we have the determinant. The first row is the x values. Sorry, the first column, excuse me. So that's -1, 1, 0, and 0. And then this is 6, 0, 5, 4. This is 3, -5, 1, and 0. 1, 1, 1, and 1. And what I have to do is, we have to just work the information out. Well, whether you work it by hand or work it on a graphing calculator, you're still doing the work, right? So, but on the graphing calculator, when I plugged this in, I did get 0. So we said that these 4 points are indeed coplanar. Well, that's what I did. And then the last bit of information in this section is the 3-point form of an equation of a plane. If I'm given 3 points in a plane, then can we determine the equation of the plane? So notice how for that first row, x, y, and z are arbitrary, and then below that we put the values that are given. So here we have the x values, and then the y values, and then the z values, right? And so we set that equal to 0 and solve. And I did all that, I can't even see. So in my graphing utility, I plug this information in. So we got the x here, and then this is 2, 5, 1. The y is there, -2, 3, and 2. Then the z is here, and this is 20, 12, 17, and then 1, 1, 1, 1. Okay. We set that equal to 0, or you can just plug in your graphing calculator, without this, and then once you get the result, set it equal to 0 and solve. Now here's what I got when I put that in my graphing calculator. That gave me 17 times x plus y plus z minus 20. Okay, but I didn't tell it equal to 0. So let's say here equal to 0. So equal to 0. So now let's divide both sides by the 17. And when you do that, that leaves us with x plus y plus z minus 20 is equal to 0. And then we just get x plus y plus z is equal to 20. Okay, and that's the equation of the plane. Pretty neat stuff, right? You've taken other classes where you've had to almost sometimes struggle to get these equations, and who knew that we could use the determinant to actually get this stuff a whole lot easier, right? So well, hopefully this will be sufficient. Enjoy.